Okay, we have the first participants coming in already, so we'll wait a few more seconds for most people to join in, and we'll start with the webinar in just a bit. All right, for those of you who just joined, we are waiting for a few more seconds for participants to join, and we'll start in a minute. All right, so I see many of you have joined already. Hello, everyone. Welcome to today's webinar on digital leadership. I'm really excited about this webinar in particular. We have a really cool use case to show you. So in today's webinar, you'll see how IoT, so Internet of Things in the lab, can help you become more efficient. We have great panelists with us. We have Liane from Technical University of Applied Sciences from Wildau, Germany. We have Steve from Gilson, US, and Lenny from Protocols.io, also from USA. The reason why this webinar is, why I'm so excited about this webinar is because, Lenny, I believe it was back in 2015, when you and I, and shortly after Steve joined the discussion as well, we were sort of dreaming how it would be awesome if we could take the protocol, you know, the PDF protocol that you have in every scientific lab, and somehow transfer it to the equipment, so the equipment would already know what to do based on that protocol, and then everything would also be magically recorded so that everybody can find any data. And you know, it seemed like such a dream, and I'm really happy to be able to be today on this webinar and to show you the use case, how what's already possible. So you'll see how we can take the protocols from Protocols.io, move it to Synode, make edits there, move that data to Gilson smart pipettes, connected pipettes, and then how Pipette knows what to do already, and then all the reporting that Pipette does goes back to the ELN, to the Electronic Lab Notebook, and can be and can update the protocol if need be. So, so it's, at least to our knowledge, it's the first practical example of IoT that includes multiple vendors, that is off the shelf. So this is available for everybody. You don't have to do any programming to enable this. And we have Liane with us today, who has applied this at her lab, and you'll be able to learn firsthand how the experience was and what are the expected benefits. So today we'll start with Liane, who will give us this presentation. We'll move then to basically questions for the panel about IoT, what are the practical uses of IoT, what one can expect by implementing it, how to implement it. So we'll try to be as practical as possible. And then as the third phase of this webinar, we'll open the questions for all the audience. So speaking of which, if at any point during this webinar you have a question, you know the drill. There is a Q&A button at the bottom of the screen. If you don't see it, just move the mouse a little bit, and feel free to post the question there. I will see all the questions, and at the end of the third stage of this webinar, we'll go through them and we'll answer them. If any questions get unanswered, we'll follow up with you over email. Also, this webinar is being recorded. We'll make it publicly available later on this week, so you'll get the link and you don't have to write anything down. Okay, so I'd like to give a few minutes to our panelists to introduce themselves so you can get to know us a little bit better. Liane, would you like to start?
Of course. So thank you for the introduction. So I'm Liane. I'm a research scientist and a PhD student in the Department of Molecular Biotechnology and Functional Genomics at the Technical University of Applied Sciences in Wildau, which is a small city near Berlin in Germany. And we have here a research group about 15 or 20 people and various projects dealing with environmental issues and medical issues and also with food analysis. I am working in the environmental sector, so I am developing mass spectrometry methods to analyze environmental pollutants, and this will hopefully result in my PhD next year. And besides, I'm also responsible here for the digitalization of our lab because we had this very nice project I will introduce later. And yes, that's it for now.
All right, thank you, Liane. Leni, you want to go next?
Sure. Thank you, Clement. It's a pleasure to participate in this, and I'm Leni Tadelman. I'm a yeast geneticist and computational biologist by training, and it was my postdoctoral research experience where I spent 1.5 years correcting one step of a previously published protocol method that led me to this obsession with creating a central place where it's easy to develop collaboratively methods and then share the exact details of what we've done with others to increase reproducibility. So that's been my passion since 2013, and I'll stop there.
All right, thanks. Steve?
Thanks, Clement, and thanks, everyone. My name is Steve DeCabiter. I'm the Director of Connected Platforms at Gilson. My team, we're building out the digital system for really for a lot of benchtop capabilities. Our first focus together as at Gilson has actually been on, as Clement said, the connected pipettes and the workflow tools that we've built out behind them. For me, this whole sphere of connectivity and helping to bring it out has been a passion of mine for my whole career. Prior to working at Gilson, I worked in cellular and telematics for where we were doing a lot of the same kind of things, but it wasn't called IoT back then.
All right, and I'm Clement. I'm a co-founder and CEO of Synode, and my frustration started when I was doing my PhD. I was handed over a paper notebook from actually a co-founder now of Synode that I had no idea. I was not able to read his handwriting, and that was sort of one of the things that made me start the company. So thank you all for the great introductions. All right, in order for us to get to know you better, we'll open up the first quick poll to see basically how digital your lab already is. You should see the poll on the screen right now. So we'll wait a few seconds for you to have a chance to read through and vote. So these questions will help us. Everybody will also see the results, and these questions will help us panelists understand our audience, and I'll steer the conversation based on these answers. So we'll wait for a few more seconds. Okay. All right. All right, we have almost a standard curve. So it seems like we have most people that use a combination of paper and digital tools. There are very few of you out there that are more advanced than that, and a few. Well, majority of people are there. So I'm really happy to see this. I think we have a lot of value to offer to you during this webinar. So I hope you'll find things useful. All right. So without the further ado, Liane, the floor is yours.
Okay, thank you very much. And first of all, it's really nice to be here today with you. It's something I couldn't have imagined a year ago. Then I never even have heard the term ELN or IoT of the lab. So this was quite new for me when we started this project. And actually it began in December when the head of our department approached me and said, oh, I have this nice project and it's only a short-term project and you can test the new workflow and some connected pipettes. And I said, okay, why not? That sounds great. Why shouldn't I do it? And that's when a colleague and me started together to do this project, and everything went really fast. So within a few weeks, we got the pipettes from Gilson and the TrackMan connected, and we had several meetings, online meetings with Synode and also Gilson, who introduced the systems, which was really great, I have to say. So I never experienced something such a good collaboration before, I have to say. Yes, and so in January, we said from one day to the other, okay, let's switch our whole workflow. So before we totally relied on a paper notebook. So this one, most of you know. And but then we said, no, we want to do it differently. So maybe to describe it a bit how we did it before or how I did it before. So normally I planned my experiments on the PC. I wrote something on an A4 sheet. I printed it and then I took this A4 sheet with me into the lab. Did my experiment, wrote everything back in this nice little book. Came back to the office and analyzed the results. Picked a few of them which seemed interesting and again printed a graph or the results, put them in the paper lab notebook, and that's it. So I used quite a lot of paper work, and it was not digitalized at all. And as I said before, in January we decided, okay, now we switch it. We got this nice introduction from Gilson and Synode. So we said from one day to the other, okay, let's start to do it digitally. So then we planned our whole experiments within Synode, and we didn't have to print anything. We just took my new best friend, which is this one here, with our protocols, and also planned some pipetting programs directly on the tablet. And then we went into the lab, and then the pipettes were connected with the tablet, and the pipetting was done almost automatically, I have to say. So the aspirating was done, the dispensing, the mixing was done to the program, according to the program I have done before. And the only mistake I could have done was to place the pipette, or to press the button of the pipette at the wrong time, but that's also something you can correct, and everything is visually and acoustically assisted. So I can say it's hard to make a mistake in the lab then. Besides, you also get a pipetting report, and this one can be directly uploaded to Synode. And that's what we did. And of course, I had to analyze the results back then in my office. And those results were saved within Synode. And now I could save all the results. So as I said before, in my paper lab notebook, there was maybe one graph or two graphs and the table of the most important data. But now I could save everything there. And besides, not only me had access to this, but also my colleague. So before, of course, I had my PC, I had my paper lab notebook, and my colleague had his stuff. And now we could see what each other was planning and what our results were, and we could directly comment it. So this was really a major advantage we had here. And besides, there were even more options. So compared to what we've done before. So with the collaboration with Protocols.io, we could also look at external protocols that we could use as a template for our own research, adapt it a bit, so we had even less work for this. Yeah, and I think there are several more things you can do with Sign.io. So and also with other ELNs probably, so you can create reports, you have your inventories there. So now you have everything in one place, which is something I really like. And we did this project for approximately 4 weeks because we wanted to do it in the short term and see what we can achieve within those 4 weeks. And both of us agreed that we don't want to go back to this one, yeah, and said we have to continue with this digitalized workflow. And even if a few weeks later, or it was a few months, our whole department decided to go digital. So now everyone here is using Sign.io, and this is really great. So it works quite good.
Okay, thank you, Liane. Maybe just a few questions from my end. How would you, let's say, summarize the main benefits of using this everything connected, everything digital? Like, what would you say? Like, what would you say to, you know, Liane before, who was maybe more skeptical about all these tools?
I wasn't so skeptical, I have to say. I like to try it out. So I think the major advantage, so first of all, of an ELN is that you have everything in one place. And as I said before, you can also create those pipetting plans and upload them also within Sign.io. So you can find also all your data there and your plans and protocols, which I think is the most important advantage. And according to the pipetting, it's less error prone, I think. So you program it before, you know the pipettes do not make a mistake, so to say, as you would do it. You have the visualization on the tablet where you can pipette, and so there are less opportunities to make a mistake there. And besides, I didn't mention before, there's also an environmental sensor included. So you also get data of the temperature or humidity during the time you were doing the experiment, and of course this could influence the experiment. So if you later think something went wrong, you can look at this data and think, oh, it was I don't know, too cold on this day because the climate control didn't work appropriately. So that's great.
Yeah, that's a great point, and Leni will get to this. But I remember that your example from your PhD also with the temperature. So this is an interesting point, and it's something like if you're not recording it, you don't even think about it. That you know it might influence. I think it's a really good point. So maybe last question before we go to the Q&A session. You know, given that you had to change your habits, you're doing work differently now, and you know maybe you can speak broadly for your department. What seemed to be the biggest challenges when adopting this? Like what is now maybe different that you don't like, that it's maybe easier with the Node system?
So we have at least two issues, so to say. One is, as you said, people like their old habits. So sometimes I have to push some people here and say, come on, you have it, we have it now here, so you should at least try it and use it. And the second thing is that we're here at the university, and it's sometimes a bit difficult to get money for hard and software. So we still do only have those 2 tablets that were provided by Gilson. So some of my colleagues, of course, also would like to have those tablets to go into the lab and not only plan the experiments here within the year end, but also take those protocols with them into the lab. But one good thing is due to the last months and what we experienced there with the Corona crisis, also our government saw that it is necessary to invest more in digitalization. So the head of our department is currently looking how we can use this to our purpose. And so we hopefully will have soon money for those tablets, and then I can convince my colleagues even better to use this.
All right, thanks, Liane. All right, I have a couple of questions for you guys. So let's start maybe with some, let's say, basic questions. Steve, you said you've been working with, IoT before it was even a thing. So could you explain, let's say, to the audience, what is IoT in the lab? What does this even mean?
Absolutely, yeah. No, so IoT is fundamentally about sensing and connectivity, and really doing that. I think that the real revolutionary piece versus just the tradition has been that the cost has come way down, right? So you get that affordability, that accessibility, and really that simplicity that creates a lot of opportunities, really across all kinds of different spots. I mean, as you heard Liane describe it, because it's come down so much, so much capability at such a good price point. Even hand tools such as like our pipettes are, we can actually we can afford to bring those in without really affecting the price. As Liane says, I mean that's a big concern in the lab as well, and and so it's really about bringing all that together, and then from there seeing how all these little data sources can be joined together through other technologies like cloud computing, and some of the algorithmic work like ML, machine learning, artificial intelligence, some of those kinds of things, to be able to get that multiplier and increase those benefits.
All right, thanks. Leni, I have a question for you. So protocols IO has been gathering essentially protocols from life sciences. I know that you have a very extensive vision of where you want to take protocols. Can you share with us a little bit how you see the future? How do you see the protocols being exchanged? How do you see, the way I know the protocol from back when I was in the lab, it was a printed out, pieces of paper that were sort of stapled together, and I would take this to the lab and then I would write some stuff on. So how will this change in the future?
So there's sort of, I don't know if I am going to use the right words, but I kind of see what we've been doing since we launched protocols.io in 2014 as a place to share method details before and during publication, and then a place to come back and keep them up to date. I see that sort of as a Trojan horse to get people to share the details so that eventually we can get to that next phase, which is what you're asking about. And right now people are mostly sharing just an online digital version of what you would write down by hand, right? Step 1, take the tube out. Step 2, thaw it at 50 degrees in a water bath, and so on and so forth. So a lot of the protocols that we have are text, but what we're sneaking in, why I use the word Trojan horse, what we're sneaking in is trying to get structure, trying to get people to use components so that you identify, this is exactly the reagent we use, this is the equipment, we ran the centrifuge at that following speed, this is the temperature of the water bath, as components. And as we get more and more away from just plain text and the more structured the protocols become, we're setting up for a future where you can connect this to the actual equipment in the lab, right? So to be very concrete, like the examples I've had since we launched in my head of what that future is, where I wanted to go, as a scientist in the lab myself, I remember on a number of occasions during my postdoc work at MIT, when I would come to the centrifuge, put my tubes in, start it, and then realize, crap, it's at the wrong speed and I've now burst all of my yeast cells, right? And it's like 3 days of work and I just lost it because I didn't carefully check. But because we're getting closer to this ability of devices to talk to the lab notebook, to talk to protocols.io, you can imagine that if I'm on step 7 and I'm supposed to use a centrifuge at 3,000 instead of 5,000 speed, right? If the centrifuge is set at the wrong thing, you get an alert, right? You don't make that mistake. And this is something that I've been dreaming about. And the reason I'm so excited about this webinar and about what Leanne was talking about is that it's not just dreams at this point, but we're getting concrete examples of that puzzle, right, coming in, where it's not just text and it's not just a pipette, but there is that communication that's happening. So then the information from the protocol is going into SignNote, is going into the Gilson pipette, so it knows exactly how much to get, and you're minimizing the chance for errors. And as Leanne said, what I thought was amazing was that you're also building up the data so you can go back when things don't work and see what changed, right? And that's that IoT of things where you have sensors and you can go back to see what's the humidity and temperature and what was different on that particular day when something failed. And what is remarkable to me is that these are not just dreams, but we still have a long way to go. You want to connect to a lot of different devices in the lab, not just a pipette and not just from one manufacturer. So there's a lot to do. But I think over the next 10, 20 years, we're going to see a lot of progress in that interconnectedness and not just detailing what we've done in a notebook or in a protocol and sharing with others, but ensuring that that can connect to the equipment, to the devices that we're using to prevent mistakes.
Mm-hmm. Yeah, I can say for us at SignNote, we've been we had to answer a lot of times, why would anybody go from paper notebooks? They are so user friendly. Everybody knows how to use one. You don't need batteries. They're really cheap. So there are a lot of benefits to the paper notebooks. But it's exactly what Leni was just saying. So by having this albeit user friendly devices around, by having data in paper format, it's hard to enable these things, which the IoT and the connectivity between different systems, which are only possible if everything is digitalized. So for us, this has been our mission to increase the digitalization of labs. And seeing this come to life and seeing this as an example, essentially. And as Leni said, we have a long way to go. But the fact that this is here and it's available to everybody, it's really exciting. And I'm happy to see where this will go. Okay, maybe a question for Leni, again for you. So Liana was talking about habits. This all requires changes of habits, and for you guys as well, right? People are so used to these PDF style protocols, and then suddenly now they have to feed those protocols in the database in a systematic way, in a predefined, let's say, templates and so on. How has it been for you? What worked? What made people, let's say, change the habits? What worked for your customers? Anything on that?
It's a really good question. And I think about it a lot, the change of habits, because that is when people ask, oh, what's your biggest competitor with protocols.io? My real answer is the biggest competitor is paper. right? It's the old habits, and getting a scientist to switch and try a new tool, whether it's protocols.io or a new piece of equipment, right? That's the real barrier. And I would go even one step further, which is we keep asking scientists to do more and more. Like over the last 30 years, it's harder to get a PhD. We ask more experiments, right? Our technology progresses, but it's not like you now can work 4 days a week instead of 7 days a week. You just are asked to do more. And so there's really good research that shows that we expect more. Each publication takes longer. There's more data, more experiments that are expected, not just you use tools and you scale up and you're doing genome-wide sequencing, so there's more data from the same amount of work. We expect more work. And that, when you then tie the realization that we're asking scientists to do more over their time, that it takes longer to get your first paper out, that it's harder to get a PhD, that the bar has gone up. Then when you tell people, oh, we want you to be more reproducible, you're adding yet another burden. Usually, if it's at the time of publication and you're saying, oh, also, can you go back to your paper notebook and write down clearly in a supplement or on protocols.io everything you've done, it helps the readers of your paper. But for you as a scientist, you've now spent more time getting to the point of that paper. And now we're asking you to do even more to make the paper more reproducible. And so asking people to change their habits, if it's going to cost them time, is really hard. And what I love about this webinar and what you were talking about, Leanne, is that you're talking about tools that are supposed to save you time, that are supposed to prevent mistakes, that are supposed to make your life easier. And to me, if we want to improve reproducibility, I think the best way to do it is to think of things that actually help the scientist, where yes, you might need to spend half an hour or an hour or watch a webinar like this or a demo of a new tool, but that tool is supposed to save you time. And instead of just punishing people or saying you need to do more when you're writing the paper or submitting it, I think if we can give things to the researchers that save them time and prevent mistakes and make our daily work easier, simpler, more efficient, that's how you can move towards better reproducibility. So you want to be the friend of the scientist, and you want that culture change to happen because they want it, not because you're telling them, bad scientists, you need to do more, you need to be better, you need to detail things and report things with you know, more attention, because we're all short on time.
Yeah. Yeah, I couldn't agree with you more. And maybe, maybe Liana, this is, I think, a great question for you. So I'm sure that, you know, as Lenny said, like it takes time initially to start to implement things, to learn, to talk about this with your colleagues. Like, yes, there is an investment, no doubt. Plus it takes some money, right? Especially if you're getting new pipettes, if you get professional software subscriptions and so on. Although a lot of those things you can also get for free. So my question is, can you comment on time? Like, was this a lot of time that went at the beginning? Do you see now saving time? Can you I don't know, estimate how much time did it cost at the beginning? How much time are you saving? I think it's a really good point, and it's something that's maybe not intuitive at the beginning because you just see a pile of work that you have to do.
So of course, in the beginning, it takes some work and some time to get used to the new workflow, and you have to think about how you organize your whole experimental setup and how you plan your individual tests, and of course, write the protocols. But I think if you have done this 1 or 2 times, or if you have your established protocols there, then you can reuse them and just make some small changes, or use the protocols from protocols.io and see, oh, that's what I want to do actually, and just maybe a different organism or a different medium, and you change those small parts. So if you know how to use it, I think it saves you a lot of time. one drawback I saw was, which is why I really like what Lenny was saying, that they are planning to do this little parts to define protocol steps, how they should look like, and that there's a communication to the system itself. Is when I used the tablet in the beginning, I had to create those pipetting plans on the tablet, and this takes a bit time. So if you do it for the first time, it's some more time you spend there. If you have your pipetting plan and just make a few changes, it's done quite quick. But of course, this would be really nice if you just write your protocol within your ELN, and then you can send it directly to the tablet and connect the pipettes, and then you can go. So this is a really nice idea I see for the future. Mm. And yeah, but as I said, so now it definitely saves some time, because this writing per hand things into this paper lab notebook, it also takes quite a lot of time. So I know I also compared it. So for those of you who are interested, I think Gilson and also Synod wrote this case study or published the case study I wrote. So you can take a look at it there, at some data for what I did there, and yeah.
Yeah, so we'll send you this study actually as part of the email that you'll get after the webinar has been published. Just to add on that note, maybe something, so one thing is to, when you're actually executing the workflow, when you're doing your lab work, that you are already saving time once you have things set up, because it's, if they're set up digitally, it's easy to reproduce. But something that we noticed when we were surveying our users was that they're saving a ton of time also when they're doing reports. And by reports, I mean like when you are getting ready for a meeting with your supervisor, when you are, when you are presenting the report at a conference, when you want to share something with your colleague. Like traditionally, this all takes time. You have to get the data together, write some text, and this is all there. Like when you have a centralized system, it takes it's then really easy. Everything is searchable. You can navigate to colleagues' workspaces and see what they did. So this makes also quite a bit of difference. But just to, let's say, conclude the habit discussion, one thing that also we noticed is that, if we want to go truly digital and if we want to enable everything that we were talking about, we essentially have to bring the digital space to the lab, which sometimes can be difficult. So maybe Steve, if you can explain how the Gilson connected products actually look like, because Liana is mentioning the tablet computer. So how does this all work together?
Sure, yeah. No, so everything, if you think about it, especially as you start talking about these, bringing in connectivity to a lot of the tools that everybody's used to in the lab, I think one of the really important parts is to try to really make them look and feel as much like what you're used to doing as you can. We've talked on and off some really good points about that importance of helping people through the change. Well, one of the things specifically that we're trying to do here at Gilson is really try to minimize the change that you even have to take in the first place. So the pipettes are pipettes, right? And so what we did is we've actually embedded within them just the ability to communicate. And with that, then, really at that point in time, you all of a sudden you have a situation where now we can build a digital system behind it, right? So the pipette is really kind of the front of it. The balance of it, especially at the benchtop, is the tablet. And on the tablet, we have an application that basically, in a lot of ways, is an automated liquid handling platform, right? You can go in, as Liana has described, create your protocol, and then be guided through the execution of your protocol. But unlike that automation robot, where it's big and it's complicated and it takes time to tune things in, what we've tried to do is again try to simplify that back out, so that again with an eye towards trying to keep some of those optimizations easier. And then I would say the real power of it then is the stuff that you can't even see at the bench, right? We talked about, just as we start bringing together the pieces and parts, we've got the integration directly to Synode. So as Liana described, we can transfer things back and forth and between the bench and the ELN and kind of go from there. And then with that, really the world is the limit. We start talking about then, with that, then the connection to protocols.io. I'd echo Lenny's dream, really is that, when we start talking about, just that experience, it should be one, what we're working towards at Gilson is really one where, that's really it's that ubiquitous connectivity, sort of that, from the minute you walk into the lab, through your entire experience, you get that benefit of the traceability and everything that you need to be able to debug and and get better quality. But it's it's a stepwise process, and so for us in keeping it small, I think in keeping it as much of sort of a transparent underlay, with what you've got, I think it's a big portion or a big part of the adoption of the system.
Okay. Thank you, Steve. So in the meantime, we got quite a few questions already. So before we jump in, we will do a second poll, which will also help us understand where your biggest challenges are. So you should be able to see the poll in just a few seconds on your screen. So here are a few challenges that we at Synode often hear about. If there are some challenges that are not here on the list, feel free to just write them in the Q&A and we'll address those. So this will help us steer the rest of the conversation for today. We'll give it a few seconds for you to go through. By the way, it's multiple choice. So if you have multiple challenges, yeah, feel free to click all of them. All right, I think we got most of the votes in. Okay, just a few more seconds. All right. Okay, all right, so we see quite an equal distribution. Maybe just to mention a few of them. So inventory tracking, protocol and SOP management. So again, you're at a great place. Team management and collaboration. Okay, we'll talk about that as well. Reporting, I already talked a little bit about this, but we'll address this. All right, thanks a lot. Thanks for this. We'll address it in the next few minutes. All right, so now to the questions. First question, is Synode a type of laboratory information management system, LIMS? So that's a great question. So I want to spend just a minute defining a couple of things. So you hear a lot about LIMS, ELNs, so electronic lab notebooks, lab execution systems, laboratory management systems. So it's a lot of words, and none of them is really well defined. One way to look at or that's how we like to look at between the difference between ELN, so electronic lab notebook, and LIMS, the laboratory information management system, the difference, how we like to see it, is if your point of view is if you're doing an experiment that is maybe every day different. So this would be a typical of academic research or R&D research in an industrial setting. You're trying different experiments, you're trying different protocols, sometimes on same samples, sometimes not. Then an ELN is the solution for you, because ELN is more centered around the workflow, around the processes and protocols. LIMS is more suited when you are running a lot of automated tests or a lot of routine diagnostic tests, where you essentially you have a sample and you want to know as much about the sample as possible. So LIMS are much more sample centric, but in reality, every LIMS has elements of the ELN, and every ELN has elements of LIMS. So it's really it's something where you have to really go down and ask each vendor and see if that what they are providing is the suitable tool for you. Leni, I saw that you would like to also add something to this, please. No? Okay.
No, I just wanted to move it to the answer.
Okay.
I should not have been clicking. Sorry about that.
No worries. Okay, then next question is, do you still experience a user variation of results with Synode after all the pipetting is more or less automated? So Liane, I believe this is a question for you. So did you see any user variation, or did you see less user variation? Like if you were doing you were mentioning your colleague, like if you were doing similar experiments, did you see that now that you've implemented the system, that there is less variability between different operators, or, you know, the pipetting and everything?
So my colleague and me, we did completely different experiments. So I was doing the one mass spectrometry method, he was doing the other one. So we didn't compare what we did. But I didn't see a difference to the things I did before. So before I used normal pipettes. And so I think there wasn't a difference. So it wasn't better, it wasn't worse. So it was reproducible, and of course the pipetting was easier. So that's really a benefit, because you can do it. The pipette, you don't have to change the volume manually on the pipettes. It's just doing it by itself. And also mixing and everything is done by the pipette. So you also need less consumables, which I didn't mention before. So you need less chips and also maybe reaction tubes and anything else. So that's also something I noticed when I use this system, which is a clear benefit. So if we're also talking about sustainability, it's not only about saving paper, but also consumables in effect.
Yeah, that's a great point. And maybe just to add to this, like I know from my experience that, you know, when you use manual pipettes, there is a lot of variation that a user can put in by, you know, how fast you're pressing, how fast you're aspirating, things like that. So Steve, I assume you've done some tests at Gilson with this, and I would assume that having this connected pipettes, that there is less variation. What's your comment?
Yeah, well, so just with the, you know, sort of that mechanical to electronic pipette, we can take a lot of that out even without. I do think, you know, there's still sources of variability, you know, but that we can't control. But what's cool is, you know, with the system, there's an opportunity to actually detect that, you know. So, you know, it's like, even if we had a partner who had actually a series of operators all kind of running the same protocol, and they did exactly that sort of a test. And what was really neat to see was they had one operator who all of a sudden yielded significantly over some of the others for the protocol that they were running. And as they started digging into it, what they found out was actually they were actually doing a critical step incorrectly. But the way they were able to detect that, which was really, really important, is that they were able to go back into the reports that they had, the specific time-stamped, you know, steps of when the pipettings actually happened, and determine that this one individual had actually made a mistake and had waited too long between steps. And So I think, you know, there's always going to be sources of variability, and I think we can take out some of them, but I think this other piece of just being able to detect some of the others sort of afterwards becomes a really powerful part of it as well for helping to either diagnose or further analyze some of that stuff.
Okay. All right, I'll take this question. So, how suitable is the type of architecture in pharma-regulated QC environment? Meaning, can there be a fully integrated and validated solution for FDA EU requirements, such as review approved by exceptional QA release? We are struggling to find a compliant lockdown platform to use for this purpose. All of this that you've seen today can be validated to adhere to regulations. Like, just as an example, Synode is used by FDA as an official ELN. With Synode, we have all the features that you require to be CFR 21 Part 11 compliant. I will say though, and this is an important fact for whenever you're choosing any vendor, like, nothing you will get is off-the-shelf compliant. You always have to do the validation internally, but do make sure that any vendor you choose has all the features that you need and all the documents you need in order to do such a validation. So for Synode, I can say that we have all of this. Steve, Lenny, do you have any experience with, I know you have experience with such settings. Would you care to comment?
I think you hit on an important point. So much of it is about the internal workflows that you have within your own company. You know, I mean, we can support a lot of those things, and we've got a lot of those elements that we can do to help enable some of that.
Yeah, Lenny? Lenny, do you care to comment?
Great timing for my internet not to be
Okay.
operating. So I heard Steve begin to talk, so I didn't hear Steve's answer. What I can say is we have the audit trail at protocols.io, but we're actually in the process of adding 21 CFR Part 11 compliance. So over the last month, we've been looking at the e-signatures. We need to add that. And I think one of the questions is when you're using multiple tools, right, it becomes harder, as in this case. So Synode might be, protocols still has a couple of weeks until it is, right? And I think the person who is asking the question in this case is right to point out that when you're using multiple tools, it does become more difficult, right, to have that control. And so we still have work to do on protocols.io. Hopefully very soon we'll be adding the support for 21 CFR Part 11 compliance, but it is a challenge and I don't have a simple answer. As Clement said, you have to check each tool and make sure that it does give you the compliance and security that you need.
Okay. Steve, I'll merge two questions for you. So first, what is the infrastructure requirements for the IoT pipette setup? And then second, how is this suitable for, let's say, undergraduate labs where you have a lot of students within the university? Yeah, how do you comment?
So I guess just quickly, I mean, we try to keep everything just kind of right to the tablet, you know, and I think, you know, even as you're taking a look, I mean, these are going to be a lot of the things that, you know, any sort of connectivity solution, you know, is going to should help with. Our solution in particular as an example, so we do have interaction with our cloud in particular, so that we can centralize a lot of the management of user IDs and things like that, specifically as well for integrations with, you know, Synode and protocols.io to be able to have that data flow going back and forth. So you need a Wi-Fi, you need to hook your tablet up to Wi-Fi, but then the pipettes themselves are just Bluetooth, you know, and so, you know, so in that respect, everything's nice and local and not really broadcasting too far. So back to specifically to the point about, you know, scalability. I think it's one of the really nice things about, like Bluetooth in particular, is we can keep everything sort of tied in, so you're not having to, everything's not trying to hit the Wi-Fi at the same time. Everything's kind of localized to your bench, and then you can kind of go from there. But it is actually a big point. I mean, as we get more and more things talking, we see it in our homes. Things start to interfere with other things, and it's a lot of. I would say it's one of the important things with any solution is just to try to make sure that I mean, there are these new dynamics of what helps to make something fit better onto the bench, within the lab, within the enterprise.
Okay. I'll again merge. So we have more and more questions coming in. So I'll merge a couple of them that are talking about connecting other equipment, other instruments. What if those instruments are offline? What if they don't have access to internet? What if they're... So this is a great question, and it's something that, as we said before, it's the dream to have all of this connected. The good news is that most of new products that are coming to the lab, most of the new lab equipment is now by default or off the shelf already cloud connected, internet, so enabled to send the data directly to the cloud. There is also a concern for, let's say, if you are in the regulated environment, the mantra is that the data shouldn't go to internet. But this is also being changed, and a lot of big pharmaceutical companies are moving everything to the cloud. So, and in terms of regulation, cloud is totally acceptable. It's more that traditionally validation was easier on the local infrastructure, although that is being changed as well. But to answer the equipment, so at the moment so it's the Gilson pipettes is the only equipment that is integrated with Synode off the shelf. So also there is a question about how to program the pipettes. So there are multiple ways to program the pipettes, but the point is, so once you've programmed it, you can reuse this over and over again, and you can use Synode to manage all these different programs and to push them to the pipettes and to the tablets, as we mentioned before. But for the other equipment, there is an open API to Synode. I know that there is an API on Protocols.io. That's how Protocols and Synode integrates. Steve, I believe there is an API coming, or is it already available?
Yep. No. Yeah, we're working on it, and to basically same idea, so that we've got something that can integrate into a broader system.
But for all of those that are looking how to integrate instruments to an ELN, we do have a project that we are only running with certain customers and with another partner. So if you're interested in connecting equipment, please do give us a shout. We'll definitely reach out and we'll try to figure out a solution for you. So all of us here are working towards that future, but it's sadly not there yet. All right, I'll try to find one last question. So I apologize in advance to those that we will not answer, but you will get the answers over the email. Let's maybe take this API. So okay, so API, with Synode, we've almost from the beginning we said we want to have an API first strategy. It's also something that we feel like it's the right way to approach the scientific community, regardless whether you are in academia or industry. Science is about connections, it's about integrations, it's about people working together, trying to learn the truth. So yes, API is essential. We do have a number of other integrations, not with ChemDraw, which was a question, but with ChemAxon, so that you can write chemical formulas. There are no connections between ELN vendors yet, but it's been actually a project that we had with Liana's professor as part of the European Commission project, CHARM, which was to standardize the data, and one of the latest endeavors was to standardize also the information between different ELN vendors. So this is also something that is part of the future, and we are right at the center of supporting this. We even have our own open source .eln file format for exchanging the information. This takes me to our last poll, which is exactly this. So what other things you would like to see connected to this kind of ecosystem that we talked about today? So you should see the question on your screen right now. So we threw in a couple of things that we hear a lot. If there's anything that's not there, please write it in the questions and answers, and we'll make sure to include that. So we'll wait a few seconds just for this to finish. All right, in the meantime, I'm just looking if there was anything. Okay, there's a question: how does Synode cope with inventory management and freezer location mapping? So within Synode, we have an inventory management system, which is basically a table, and in this table you can program to have freezer location, sample information, you can attach files to them. So it looks more and more like LIMS, that part. So you can manage those things. And there was just one question now regarding the Synode LIMS, how is part 11 compliance resolved? So it's a complex question. So I will follow up with a document that explains this. But in short, it's about having electronic signatures, and it's about locking the activity within your ELN so that nobody else can come in. And it's about inviting others that need to co-sign, and then having all this traceable in the audit trail. So that's very much in short, but the features are built into the system, and those that you don't need, you don't see essentially. Okay, so we reached now the end of this webinar. So I hope it has been as useful for you as it has been exciting for us. I hope you felt the excitement of the team, and we are really happy to be here. So it's been great having you. Thank you for all the questions. Have a nice day. Keep an eye out on your inbox for the email, so that with the recording of this webinar. Thank you all the guys on the panel. So it's been a pleasure working with you throughout the years, and yeah, thanks for taking the time today. Stay safe, everybody, and see you all next time. All right. Bye, guys. Bye, everyone.
Bye.
Bye.
Thank you, everyone.
Thank you.